I normally get a lot of questions about how to understand the different maps that I ask you to make. I ask you to make, for example, a map showing the top of the limestone, a map showing the pre-quaternary surface and the sediments at the pre-quaternary surface. And you're also asked to make a map of the soil types in the area. Before starting on explaining the different maps, I would like to state what we talk about when we talk about levels. Here to the left, you can see the levels where 0 is defined by the sea level. So sea level is 0 meters, and if we move above that, we put a plus in front of the figure. For example, the top of this hill will be lying in approximately plus 75 meters above sea level. And this surface here will be lying at minus 350 meters below sea level. So this is important because if we want to compare geology from two different sites or two different drillings, we have to do it according to sea level. First of all, I can explain a little bit about the geology on the cross-section you see here. The cross-section could be from many places in Jutland. We have the limestone lying close to surface, so it might be, for example, in close to Aalborg, but could be many places in Jutland. At the bottom, we see sediments from the Upper Cretaceous. This is white chalk, the chalk that you can write on the blackboard with. Above that, we have Danian Briarstone limestone. You would want to write on a blackboard with this kind of limestone. Above that, we see Paleogene plastic clays, and on top of Paleogene sediments, we have the Neogene sediments, this mainly being mica clay, mica sand, quartz sand, and brown coal. These are all pre-quaternary sediments, meaning they have been deposited before the quaternary time period. And the quaternary time period are the period where we have the glaciers, the glacial times and the interglacial times. So these are quaternary sediments deposited in the quaternary time period. So when we talk about pre-quaternary sediments, they define all the sediments before the ice ages. But let's look at the different surfaces. First of all, I've asked you to make a map of the top limestone. I've marked this now on the geological cross-section here. You can see this is the top of limestone. Here it's lying in approximately minus 100, meaning 100 meters below sea level, and close to the seabed here. And it is falling down to minus 350 meters below sea level here. So in this place, we will have more than 400 meters from terrain to the top of limestone. I would say that if the top of limestone is lying close to the surface, from 20 or less meters below the surface, then we would have to consider if it would have any impact on our project. There could be sinkholes, there could be other problems. But let's take off the top of the limestone. That's one map I ask you to make. Then I ask you to make a map showing the pre-quaternary surface. There are two maps describing this surface. First of all, there's the level of the pre-quaternary surface. That's what you see here. In this case here, the pre-quaternary surface is lying in approximately 0 meter, meaning close to sea level. And there's a distance of approximately 40 meters from terrain to the pre-quaternary surface. If we look at it here, then the pre-quaternary surface is lying pretty deep according to terrain. And here it's lying again approximately 50 or 75 meters below terrain. So this is the level of the pre-quaternary surface, one of the parameters that define it. We have another parameter, and that's what is the sediment type lying at the surface of the pre-quaternary surface. You can see that here it's neogene sediments, and here we have Paleogene sediments. Here we have Neogene again, and here we have Danian sediments and Neogene. I've tried to illustrate it up here on this. This would illustrate the map of the pre-quaternary surface, meaning what sediment types do we have at the pre-quaternary surface. Then finally, we have the soil types of the area. The soil types, the map of soil type have been made by geologists running around in the terrain and making very small drillings to 1 meter below terrain, so that they just reach below the topsoil. And then they look at what kind of sediment type do we have here. Based on that, they have made the map of soil types. And if we look at it here, that would mean that here we have moraine clay, here we have late glacial meltwater clay, here we have post-glacial freshwater peat, moraine clay, meltwater sand, moraine clay here, and now we are underneath the sea level, and there will be another kind of map showing what sediment types do we have at sea. But the map of soil type only covers onshore Denmark. These are the colors used on the map of soil types, and that's how to interpret the moraine clay, meltwater clay, freshwater peat, moraine clay, meltwater sand, gravel, and moraine clay again. So I hope that this small illustration has helped you understand the different maps and the different surfaces that you've been asked to look at.